This lecture is the last lecture for the first half of this course. The thing that we're going to talk about here, basis, this is the culmination of everything that we have seen so far, which is the span and linear independence, and also vector space. You see, a well-known application of basis and the reason why linear algebra is in the heart of machine learning in the first place is the recommendation engine. Human preference is, after all, highly dependent. If you give me a list of movies that you like, I can look through those and recommend a movie that maybe you are going to like as well. Yeah, what we like and don't like is not random. It has something to do with each other, like in this example. Let's say I have a rating score for 5 movies from 6 viewers here. Now, let's say if I have someone who likes movie 1, but does not like movie 2 and does not like movie 4, should we recommend movie 3 or movie 5 to that person? Now, if you look through the rating score that we have here, maybe I can look at viewer 3 who like movie 1, does not seem to like movie 2, and it's also with movie 4, but this person actually gave a perfect score to movie 3 and movie 5. And if you look at the score from other viewers, then for now, it's kind of a little hard to guess whether this person would prefer movie 3 or movie 5. So we actually have to do some real math with what we are looking at here. So what I'm going to do is I'm going to turn each of the rating score here into a vector. So I'm going to look at each of these little 6 ratings, the ratings from the 6 viewers as a vector. So I'm going to have 6 vectors here. And I would like to just extract the core information from this rating score. What I would like to do is I would like to condense all this into its minimal representation. This minimal representation is called a basis. We're going to talk about how can we find a basis of these vectors in a moment, but for now, let me just say that if we were to find a basis for these, what we're going to get is the vector 1, 0, 1, 0, negative 1. The next one is going to be 0, 1, 2, and then 0, 3. And the next one is going to be 0, 0, 0, 1, 2. Yeah, so instead of looking at all this bunch of weird, confusing numbers, I can extract the core information. I can look at the basis, which is going to be just these 3 orange vectors. And now, I need to find the preference of someone who liked movie 1, which doesn't like movie 2 and movie 4. So what I can do is I can try to find a linear combination of all these 3 orange vectors so that the result is something like I should have a high score from movie 1 and a low score from movie 2 and movie 4. So let me just say 0 for movie 2 and then 0 for movie 4. So what I can do is I can find a linear combination of orange vectors by, I'm just gonna multiply the first one by 10, the second one by 0, the third one by 0, and add these all together. And what I'm gonna get is I'm gonna have 10, 0, 10, 0, and negative 10. Yeah, it's a little bit extreme, but this kind of fit with the person that we have in mind. This purple person would be someone who really likes movie 1 and doesn't like movie 2 and doesn't like movie 4. And now it is now clear that this person would much rather watch movie 3 than movie 5. Notice how from the information that we have earlier, it's not clear whether we should recommend movie 3 for movie 5. But once we extract the basis and do some computation, now it's very obvious that this person would prefer the movie 3.